To change speeds on this machine, as in spindle speed, there's two different things that you have to do. There are two gear ranges, a high range and a low range. When you switch from high range to low range, you move this lever to the side, and now you're in low range. And this will give you spindle speeds from 80 to 325 RPM. To switch to high gear, you move this lever to the right, move this lever forward, and then you have to move the pulley until it drops down like that. Otherwise it'll make a horrendous noise that sounds like you've destroyed the machine. It's really just a dog clutch not aligning inside the head. Not a real big deal, but it's embarrassing if anybody's around, and it's just not good for the machine. So that's how we change from low to high gear and from high to low. In addition to that, there's also 4-step pulleys, 4 on this side, 4 on this side. In order to change the belt position, you loosen this lever and you can pull the motor towards you. With this, I just use this, it works fine. I don't know why this other lever's here actually, it doesn't need to be. And then, whichever way you're going, you move from the large to the small pulley first. And then move from the small to the large pulley on the other pulley. And then tension the belt and lock it in place. That's probably what this is for, to give you a better handle on that. But all the Bridgeports I've ran only had this, so I'm kind of used to just pushing on the side of this. And these phony baloney guards go on here, but as you just saw, they tend to fall off. I don't use them, but I recommend that you do. And that's how we change speeds on this milling machine. The ram on this upper portion here is called the ram. Moves in and out. It sits atop the turret. So that is one thing that's different about this machine than others that I've seen. These two gib adjustments. I've never seen these on any Bridgeport clone before, although I'm sure they were there, I just didn't notice it or something. These bolts hold the ram in place. If you loosen them, you can then use this pinion to move the ram in and out. This is really handy if you need to get on one side or the other of the table. For example, if you have a long piece bolted to the front of the table and you need to work on the end of it, this gets you out past the end of the table. So, the manual says to grease these once every 40 hours. I don't think I've ever seen them greased ever in industry. Doesn't mean you shouldn't. There are also 2 bolts here and 2 bolts on the other side of the turret. You loosen these and then you can swing the whole turret around, bringing the ram over to one side, or even attaching an accessory like a slotting head to the back of the ram. You can then have 2 heads on one machine. Let's talk about electrical requirements for this machine. You'll need to have 220 volts single phase power available, and you'll also need 110 volts single phase available for the machine. Air would be something I can't hardly imagine working without on a machine like this. So that's another thing that swayed me in the direction of this machine. The used Bridgeports out there are 220 volts AC 3-phase. Yes, you can run those on a variable frequency drive or a rotary phase converter. But this, all I had to do was run wires to the circuit breaker panel, put in a breaker, and you're done. So it's significantly easier to hook up and less expensive. All you need is some Romex cable. We did a number of tests on the digital readout. The most important of those was how repeatable is this digital readout. Now, in order to determine that, we took a brand new 4-inch gauge block and a very, very precise brownish sharp 1/2-inch edge finder. And there were two of us here. My friend was here for that test. And what we did was we put the gauge block into the vise, as you see it here, and then we each picked up that edge 10 times. Well, this was more precise than I was by 50%. I mean, he was incredible. He mostly had zeros and oftentimes had 1/10,000th of an inch variation from edge find to edge find. I was about 2/10 off. So he did the test, and the object was to pick up this edge, zero the indicator or the digital readout, and then lift up and go all the way to this edge, four inches away, come down and indicate or pick up the edge. That should have been 4.5 inches. And what we did was we marked down the error from that. Measuring the 4-inch gauge block, made 10 measurements, and the total for the entire, if we added all of the error for those 10 measurements, we got 5 thou and 2/10 for 10 measurements, which means if we divide by 10, the average was 5/10 and 20 millionths. Now that's for a 4-inch measurement. We divide that divide the 5/10 and 20 millionths by 4, and we get 1/10 and 30 millionths per inch of error. Notice I've used some blue tape over here to blot out that 5th digit, which doesn't mean anything. So 1/10 and 30 millionths per inch is pretty darn good. I'm more than happy with this digital readout, except for that, which I can see through the blue tape, but I'm sure I'll never need to. So that's wrapping up our report. I hope you found this basic review, this first impression video, to be helpful. I know it probably would have helped me if I'd been able to see this before. I just studied the heck out of the photographs on the Grizzly website. It's important to note that I don't have any affiliation with Grizzly whatsoever other than being a customer. They don't give me any free stuff or anything to say nice things about this equipment that I have purchased from them. It's because I've used it that I feel that it's good equipment and that they stand behind their products. So thank you very much, and I hope this helped you. Have a good day.